Hello, in this video, I'm going to walk you through the squares example. So I'm going to grab the example code from GitHub, and then I will open a edit buffer using Racket. So I'm going to run it and also show you how this is how this works. So here we define square as a simple function. So this is pretty straightforward. And then we want to create another function called squares. Another procedure that implements the function called squares. Given a sentence, we're gonna square the numbers in the sentence. So we assume the sentence is made up of words, and each of which is a number, so it can be squared. Okay, so how do we do this? So this is a recursive solution because when we define the procedure, we use the procedure itself. So this is a recursive thinking. Also depends, based on how a sentence is structured. So a sentence, we have a helper procedure called first. So first will always give us the first element in the sentence, and then we have but first that will give us the remainder of the sentence. So squares is implements a function that given a sentence, it returns a sentence. So its domain of the function is a sentence, and its range is also a sentence. Okay, so okay, I'm gonna run this. We use the trace, so this will gonna display or print all the calls, each and every call on this procedure, each invocation on this procedure. So I'm gonna run the definitions. I'll copy and paste the test case to the interactive window, and now we get this result. So the result is in blue, so it's correct, and this is the process. So in the squares procedure, given a sentence, we're gonna first check whether it's empty, right? If it's empty, then the answer is straightforward. It's empty. Otherwise, we can always take the first of the sentence, okay, because it's not empty, and square it, and then delegate the rest of the task to squares itself, because we are defining a function that called squares that can square any sentences. So this is a bit of wishful thinking, but it works because it's this function, this procedure can refer to itself. So we pass in the but first, the remainder of the sentence, so that should square that, and then we take the result of square and squares, and we use sentence, this constructor, to build a new sentence consist of the squared first element and the squares of the rest of the sentence. Okay, so this is a recursion, and this is how it works. So here is the trace, the output that shows the calls on squares, and then the return value. So initially we're gonna call squares with the original the input, right, the original list, and well, it's not empty, so we're going to evaluate this part. But before we build the sentence, we need to calculate the square of the first element, which is easy to do. We just call that function, and then we recursively call the same function squares to square the remainder of the list. So given a list, it's going to return a list that is squared. So we call squares again, but this time with a shorter list, right? Imagine when this is evaluated, we're evaluating the same code as defined here in this procedure, but the sentence, the input has changed. It's 2, 3, 4, 5 instead of the original one. Okay, so we execute the same logic, right? It's not empty, so we're going to do the same thing. We'll square the first, which is 2, and then call squares again with the remainder of that list. And note that this sentence, this is a constructor call, happens after both square and squares returns, right? Because we cannot build a new sentence before they return, and that's a bit of a pending operation that can only happen after the return from this recursive call. So in the output, this is how we can tell. So every time we make a recursive call, this is the display is indented by one space, right? And then when the procedure finally returns, the output is listed at the same indentation level. Okay, so that's help us understand. So as you can imagine, right, as the squares, it gets called recursively with a smaller and shorter sentence. Eventually, when we call 5, the sentence with only one element is still not empty, and we're going to recursive call squares, but use the but first, right? The but first of this is actually empty, right? Empty is a sentence that is empty with no words. Okay, that when it's evaluated, it's going to hit this base case. So the answer is clear. It's empty list. We don't recursively call itself. So this gonna return empty list. Okay, recall that before we call this, well, after we call this method, this procedure called returns, we have a bit work left to do, which is to construct the new sentence with the square of the first element. So when this call returns empty, and then the previous call can return, right? But this, when they to return, we have to complete the remainder of the work left to do, which is to construct the sentence using the first, which is 5 squared, and then concatenate that or construct a new sentence out of that. So 5 squared is 25, and put in an empty list. Empty sentence is a sentence of 25. Okay, so once this returns, now the previous call can return. So it's the same deal. So we're gonna have a so when this so after this returns, we need to construct a new sentence. To return from this one, we need to construct a sentence with the first element squared and the remainder of the list squared. The remainder of the list squared is this, and the first element 4, so the return of this call is gonna be this. Okay? So now we have another partial list all squared. And then once this returns, now this call can return, which will take the result, which is 4, 5 squared plus the first element squared, and then in a new sentence. So this call will return this. Okay, and now this can return. It's the same thing. We take the squares of the sentence, and then take the squares of the first element, and then put it together as a new sentence. Okay, once this returns, this can return. Okay, it's the same thing. We square 1, square the remainder of the list, and put it together as a new sentence. So that's why we get this result. So this is a common pattern in this kind of recursive programming. We define a function in terms of itself, and when we make recursive call, we passing a smaller version of the problem. So eventually it's gonna hit the base case, and then on our way back from the recursion, we put the result back together. So this is a very common pattern. We're gonna practice again and again. So that's it.